Everyone, welcome to the channel, and today I will show you how to calculate the nitrogen dioxide concentration for any study area using time series chart analysis using our dataset called Sentinel-5P NRTI NO2. So let's get started. So to calculate the nitrogen dioxide concentration in atmosphere for any study area, first we have to import our country's boundary layer into Earth engine. So to import our country's boundary layer into Earth engine, we have to define a variable called countries equals to feature collection USDOS LSIB simple 2017. The next we have to import our Sentinel-5P NRTI NO2. So to import that data, we define a variable called collection equals to image collection Copernicus S5P NRTI LS NO2. So in that we're going to specifically select a data called NO2 column number density. So for that we define dot select NO2 column number density. So we're going to filter with a specific time period. For that we define dot filter date 2020 January 1, 2020 December 31st. So next we have to set up a visualization parameter. To set a visualization parameter, we defined a variable called bandwidth. So here we are representing a minimum value of 0 and to a maximum value of 0.0002. And we have to represent our nitrogen dioxide concentration in different colors, starting with the lowest. The lowest nitrogen dioxide concentration is represented in the black color, and the highest concentration of nitrogen dioxide is represented in red color. So for that we define this palette, and starting from black to red. So black indicates the lowest concentration and red indicates the highest concentration. So next we have to display and visualize our layer. So for that we define map.add layer collection dot mean function dot clip countries. So band visualization, bandwidth here represent our band visualization, and output the layer name as S5P NO2. The next we have to import our Sentinel-5P image. So that is to create a time series chart analysis, we have to import our Sentinel-5P. So for that defined our variable called start time, that is the initial start time period of the satellite and the end time period. So start time we define from 2020 January 1 to our end time defined from 2020 December 31st. So we have defined a variable called NO2 collection equals to image collection Copernicus S5P NRTI L3 NO2. So we are filtering with a specific study region. So suppose if you want to identify the concentration of nitrogen dioxide for a specific study area. So here I have used a specific polygon. So here let me show you that. So we have created a polygon, so that is for Chennai. So in order to identify the particular if you want to identify the nitrogen dioxide concentration for the particular study region, so for that I have used this particular polygon. So to view the concentration of that particular region, so for that I use this particular polygon. So to create a polygon, it is simple. Let me show you that. So I have defined a variable called geometry polygon. We have 4 vertices. Suppose if you want to create a polygon, now let me delete this. So I have deleted my polygon data. So to create a polygon, so now let me show you that. So you can visualize there is a nitrogen dioxide concentration in this study region. So let me select this particular study area. So for that click this option called draw a rectangle. So I have clicked this option. Now let me draw a rectangle around the study region. So I placed a polygon around the study region. So that is indicated here, a variable called geometry polygon 4 vertices. So here I have created to filter with a specific study region. So I have used dot filter bound geometry. The geometry here represents our study region. So this specific this polygon, and to filter with a specific time period we using dot filter date, start time and end time. So here the start time represents from January 1 January 1 and 2020, and the end time here represents our 2020 December 31st, and start to end time. And in that we're going to specifically select the NO2 column number density. So next, to acquire mean concentration, to acquire a mean nitrogen dioxide concentration for each month, we define the specific function called dot map function A, return a dot set month, image A dot date and dot get month. So to view this information, we can use this option called print NO2 collection. So here the NO2 collection represents this variable. So next we have to calculate the mean nitrogen dioxide concentration for each month. So to calculate the mean nitrogen dioxide concentration for each month, so we define a variable called months equals to w.list NO2 collection dot aggregate array month dot distinct. So here to extract the distinct month present in the collection, we are using an aggregate array and distinct function, and then you map over the months and calculate the mean nitrogen dioxide concentration for each month using a filter metadata and mean, resulting monthly mean image are stored in our new image collection called NO2 final. So it is stored in this image. So we have, for that we defined a variable called NO2 monthly concentration equals to months.map function x and return NO2 collection dot filter metadata. So month equals x dot mean set month. So all of our mean nitrogen dioxide concentration will be stored in this variable called NO2 final equals to w.image collection dot from image NO2 monthly concentration, which represents this specific variable. So next, to create a time series chart, we have to define a variable called chart equals to ui.chart.image.series NO2 final. So NO2 final here represents this specific variable, and geometry here represents our study region. So this specific study region, and dot dot reducer mean, and output the layer as month. So next we are setting a certain options for our chart, that is our time series chart. So for that, to set those options, we define dot set options. Title we represent as NO2, that is nitrogen dioxide concentration. In v-axis we represent the title as concentration in microgram per meter square, that is concentration of nitrogen dioxide in microgram per meter square. And in h-axis we represent month. And to print this chart, we define print chart. So now let me go to the option called reset. Let me click this. Now let me run this option. Run the script. Click run script. So now let us visualize our result. So now you can able to visualize we have a one layer called S5P NO2, that is our nitrogen dioxide concentration, and we have our time series analysis chart. So it is represented in that is the concentration is represented in y-axis, and the months is represented in x-axis. So concentration of nitrogen dioxide in microgram per meter square and in specific month. So now let us visualize that. So let me click this option. So now you can clearly able to visualize the nitrogen dioxide concentration in different month in 2020. So starting from January to December. So here in y-axis we have our concentration of nitrogen dioxide in microgram per meter square, and in our x-axis we have months. So we can visualize in the month of January the concentration of nitrogen dioxide was very lesser. So it was around from 0.0054 microgram per meter square to is around 0.00056 microgram per meter square. So in the month of June, we have observed the highest level of nitrogen dioxide concentration, that is around 0.00071. So the concentration of the nitrogen dioxide was observed to be 0.000071 in June. The concentration was very higher in June, and comparatively in the month of so in October we have observed the concentration is around, so it is around 0.00067 microgram per meter square, and similarly it gets reduced in the month of December. So now let me get back to Earth Engine. So here you can visualize that. So let me show you that. So the graph here represents our nitrogen dioxide concentration for this specific study region, so which is indicated for this specific study region in Chennai. So suppose if you want to view the nitrogen dioxide concentration for the different study region, you can create a new polygon on that specific study region, and you can visualize the nitrogen dioxide concentration using this time series chart. So now let us visualize the nitrogen dioxide concentration in India. So here in this part of this country called India, you can observe the nitrogen dioxide concentration. So here already I have shown you that. Let me show you that the highest concentration of nitrogen dioxide is represented in red color, and the lowest concentration of nitrogen dioxide is represented in black color. So here you can visualize the different part of the specific study region. So this specific study region has a concentration. So few of the areas indicating few of the study regions in India have a concentration is higher. It is easily absorbed in this using this place mark. So you can observe here the concentration is very higher in this specific in this region. So the nitrogen dioxide concentration for this specific study region, that is Chennai, it is represented in this graph. So in y-axis we have the concentration of NO2 in microgram per meter square, and in x-axis in month. So in this video I have shown you how to calculate the nitrogen dioxide concentration in microgram per meter square for any study region using time series chart analysis. So thanks for watching, and please subscribe to our channel and give us a like.